What is the matter?
I'm sick of always having all these problems.
Identify with this. Buying the wrong resin for your process because you don't know the weight molecular number. Ignoring the viscosity of your polymer and applying too much injection pressure. Heating your pellets and not knowing the TJ values of the polymers.
It seems that all of your problems can be solved through polymer characterization.
Characterization?
Yes. Let me explain. Polymer characterization is an analytical branch of polymer science. We have two types of characterization techniques, physical and chemical.
Whoa, I've never heard about those methods before.
With chemical methods, you can obtain the molecular weight by using colligative properties like boiling point elevation, freezing point depression, osmotic pressure, and vapor pressure lowering. However, these methods are inaccurate because the measurements depend on different parameters that sometimes you can't control, like pressure, the atmosphere, and temperature. On the other hand, with physical methods, you can get more exact results because they are done at controlled parameters.
We can divide physical characterization methods depending on its purpose. Some of the characteristics which are usually analyzed in a polymer are thermal transitions, mechanical behavior, molecular weight, the flowing behavior, morphology, among others.
Whoa, more dogs! Tell me more about these characterization methods.
Let's start with determination of the molecular weight of the polymer chains. To do this, we can use an instrument called SLS, which stands for static light scattering. This characterization method employs a laser that is refracted to a polarizer and focuses through the sample. After the laser touches the sample, the light is scattered around the container and the light is therefore collected through several photomultipliers that measure its intensity. Then, with a mathematical approach, the molecular weight can be measured. As a result, you can obtain a weight distribution in which the highest point of the peak shows the average molecular weight of the polymer.
Whoa, that sounds easy. What else can you do?
Well, not only the molecular weight is important, but also the morphology.
Another dog? This is amazing!
This can be analyzed through scanning electron microscopy. This characterization method employs a focused electron beam that interacts with the analyzed sample. This interaction between the electron and the sample generates an electron image, which is shot back to a detector and with a mathematical correction transforms the electron pattern to an image of the sample. This equipment can determine morphology of sample with a size from 1 to 100 nanometers.
1 nanometer? That's really small. Is that all you can achieve with characterization?
No, if you want to analyze the thermal properties of your polymers, you shall pay attention of what's next. DTA stands for differential thermal analysis. The system works by connecting two thermocouples to the voltmeter. One of these thermocouples is placed in an inert material, such as aluminum oxide, while the other is placed on the sample of the material under study. As the temperature increases, there would be a brief change on the thermogram that indicates a phase transition. This change occurs because the input energy transmitted through the thermocouple affects the latent heat of the sample during the phase change. However, after this occurs, the heat is incorporated to the analysis. With this, you can obtain a thermogram of your sample that will show the phase transition, including the glass transition temperature.
I didn't know that thermal properties were so important. What is the next characterization technique?
If you are interested in analyzing the mechanical behavior of your polymer sample, you can use dynamic mechanical analysis or DMA. This is a technique that does a small deformation to the sample in order to determine the stress, elongation, frequency, and other parameters. These instruments allows you to do different kinds of tests by changing the geometries of the instrument's tip. You can do compressive, extension, shear, and flexure. In the compressive test, you can determine the force required to deform your material. Meanwhile, in the extension test, you can get the force required to break your sample. On the other hand, the shear test measures the response of the sample when a force is applied to it. This test allows you to get the viscosity values. Finally, on the flexure test, a tip drills the analyte and the equipment measures the force required.
The world of characterization is amazing. I want to know more.
We will talk about one more technique. If you want to study the flowing behavior of the polymer, you can use the melt flow index, which is generally used in the industrial area as a fast rheological test. It determines the amount of polymer mass in grams that pass through a capillary with a defined diameter and length. The procedure to do this test is by removing the piston of the equipment and adding the resin to the heated barrel, where it is compacted and allows the equilibrium. After a few minutes, the weight is added to the piston and the resin flows through the orifice at the barrel bottom. This technique is done at a fixed pressure, temperature, and weight, dictated by ASTM, American Society for Testing a Materials. This method D1238 that establishes the condition for each polymer by doing this test. You can determine the apparent viscosity and know if the resin is the one that you need.
I feel like I have learned so much. Can you tell me about the advantages and disadvantages of each method?
I will gladly tell you some advantages and disadvantages of every method so you can determine if you can use it for your sample or not. First of all, some advantages of static light scattering are that the results are well defined and they do not depend on an empirical correlation. Some disadvantages of SLS are that the sample preparation needs a lot of precaution and it has time-consuming measurements. Titan, help me with SEM. Woo!
For SEM, the advantages are that it has high resolution. It is fast, it has large magnification intervals, and it gives direct imaging of the surface. Disadvantages of this technique are that it needs to be operated in high vacuum and the sample is decomposed by radiation.
In the case of DTA, the advantages are that it can be used at very high temperatures. It has highly sensitive features and transition temperatures can be determined accurately. However, in the bad side, DTA needs calibration and a reference sample.
An advantage of DMA are that it can be used to determine thermal and mechanical properties and you can change the mode of the instrument by changing the test. As a disadvantage, DMA transfer requires a DMA controller to carry out the operation so the cost of the system increases.
Finally, the advantages of MFI are that it is fast, cheap, and the method is standardized. However, it is not so exact and it greatly depends on the operator. Now that you know more about characterization, would you like to talk to some experts?
Are you kidding me? I would love to.
Let's get to it.
El manejo de las muestras.
¿Sí?
Sí.
¿En qué sentido? O sea,
De la manipulación, sí. Sí, de que... Ese es el más común, o sea, de que todos vienen y, por ejemplo, los que trabajan con fibras, pues les da lo mismo agarrarlo con las manos que con los guantes.
Sí.
Entonces, aquí, por ejemplo, cuando son polímeros ya sólidos, o sea, que es ya un sólido, hacemos una limpieza con alcohol y si es resistente a la acetona, lo colocamos en acetona y alcohol isopropílico. Pero por ejemplo en el caso de las fibras pues no puedes hacer eso, o sea, lo que haces es recortar de la parte más del centro de la muestra, del cuadrito, el centro.
I believe this is a mistake in which students, professors and scientists can relapse, and that is a challenge in which we should be more cautious.
El peso molecular no, pero lo que es tamaño partícula y potencial Z sí. De ese sí tenemos estándares. En el DLS mide siempre y cuando tu partícula sea esférica. Si no es esférica, pues no esa técnica no aplica. Bueno, cuando son aplicaciones ya específicas, o sea, todo lo que es la parte médica y aeronáutica está muy regulada. Entonces, si tú ya tienes una aplicación específica, aquí los chicos casi todos son para dispositivos médicos, entonces la parte médica sí está muy regulada y tienes ciertas especificaciones que tienes que cumplir.
I have an idea. We could create a consulting company in which we help other businesses to have all the characterization standards. This, in order to have accurate measurements and to avoid them all the drawbacks I had back in my job.
That is a great idea, man. Mainly because there are some areas of research that have a lot of regulations.
This has been very useful for me since now I know how to prevent all the problems that I used to have because of my lack of characterization. Thank you all, Frida, Echo, and Titan. You have not only saved Mexico, you have saved mankind.